Okay, so today we are going to talk about conic sections. Okay, what is a conic section? All right, here I have these pictures of what we call a double-naped cone. Okay, it's basically two cones meeting at their vertex. This way. And what we do is we can take a plane and we can cut it through this double-naped cone at different angles, and it will create different shapes. Okay. So here is our double cone. If I put a plane through parallel, we get a circle. If we put a plane through at a little bit of an angle, we get an ellipse, which is kind of like an oval. Okay. It's a squished circle, if you will. If we cut the plane through so it's going through the bottom of our cone, we get a parabola. And then if our plane is cut through both cones, we get kind of two parabolas going away from each other. We call this a hyperbola. Okay. Now, this is a 2D picture, kind of. So what I would like to show you is a little video so you can actually see this in a 3D figure. Okay. Not super fabulous, but you can get a better idea. So here's our circle. Our plane's cutting through, and you can see the purple circle. Okay. Here's an ellipse. You can see we're kind of at an angle, so we get more of the oval shape. Okay. Here's our parabola. It's cutting through the bottom, so you can see that green parabola. Okay. And now this purple one's cutting through both, so we kind of get the two parabolas away from each other. This is a hyperbola. Okay. Okay, so a conic section, okay, we just talked about the different shapes we get when we intersect a plane with this double cone. Okay, algebraically, it's going to look something like this. Now, all of these variables do not have to be present. Actually, the ones that are missing will kind of tell us what kind of conic section it's going to be, as well as whether those coefficients are positive or negative. All right. But if we have any one of these variables or constants present, we have a conic section. Okay. Something you're not used to seeing in there is an xy term and a y squared term. Okay. We are going to go through parabolas today and tomorrow. Friday and Monday we will discuss ellipses. Tuesday and Wednesday we will discuss hyperbolas, and then have a quiz before we're off to spring break. Okay. Now, each conic section is going to have a geometric definition. Okay. You are familiar with a couple of these conic sections. The first one you're familiar with is a circle. You graph them in geometry. Yes? Okay. What is the geometric definition of a circle? What's true about all the points on the circle? They're equidistant away from the center. Okay, that's the definition of a circle. So we have a fixed point, which we consider the circle, and all the points on the circle are the same distance away. That's the geometric definition of a circle. Okay. And then of course you remember this: x minus a squared plus y minus k squared is the radius squared. Okay. That's how you identify the circle, where r is the radius. Okay. Now we will talk more about circles when we discuss ellipses, because circles are special ellipses. But that I wanted to show you what a geometric definition looks like. Okay, every single point that satisfies this circle equation has the same distance to the center. Okay, it's the radius away. Okay. Today we're going to talk about parabolas. Now you've graphed parabolas before, correct? Okay. We are going to graph parabolas in a little bit different way. We're still going to have the same shape, but we're going to talk about the properties that a parabola has. What's the geometric definition of a parabola? Okay. All you've ever done is graph kind of an arch shape, right? You know you have a vertex, and you know that there's an axis of symmetry. But there's actually a little bit more to a parabola that you haven't discussed before. Okay. So what is a parabola? Okay. A parabola is a set of points. Okay, so all the points on a parabola that are equidistant from a fixed line, which we call the directrix, and a fixed point, which we call the focus. Okay. So every single one of these points on our parabola is the same distance from the focus, our point, and the directrix, our line. I will go into a little bit more detail, but I'll wait for you to write down if you are writing something down. So this red right here is our parabola. Okay. Inside of our, in this dotted line here, this blue line, that is our axis of symmetry. That is what you're used to seeing. Okay. Now, along our axis of symmetry, inside of our parabola is a focus, our special point, which we will plot when we graph these. Okay. Outside of our parabola, okay, here sitting underneath is this horizontal line. Or what I'm going to describe it as a line perpendicular to the axis of symmetry. Okay, this is our directrix. So every single point along this red parabola is the same distance from the focus as it is the directrix. So this point right here, okay, notice how we are 2 away from the focus and 2 away from the directrix. Okay, this point right here is the same distance from the focus as it is to the directrix. This point up here is the same distance from the focus as it is to the directrix. Okay, we can go ahead and measure all those distances. We're not going to, but every time we pick a point, the distances are going to be the same from the focus as it is the directrix. Okay, that's what makes a parabola special. Okay. So when we go to graph a parabola, what we are going to do now with this knowledge is we'll graph the parabola, but we'll also graph the focus and the directrix along with it. Okay? So what I want you to notice about this parabola, and all parabolas, is the focus is going to be inside of the parabola, and the directrix is going to sit outside. Okay? The directrix will always be perpendicular to your axis of symmetry. Okay? So, I am introducing to you 2 new things about the parabola. We're going to have to be able to identify those things. All right? So the first thing I want to talk about is what does a parabola look like in standard form? Okay? You are used to seeing y equals x squared plus 2x plus 3, and then you find the vertex, and you make a little xy table. You find a couple other points. Okay? That's not what we're going to do, and we're not going to look at the form y equals x squared plus 2x plus 3. We're going to look at a form that's a little bit different, so we can just look at it and identify our vertex right away. Okay? So first of all, okay, we're actually going to have parabolas that open vertically and horizontally. Okay? First, we'll talk about the comfortable ones, the ones that open vertically. Okay? So this is our standard form here. Notice how the x minus h is squared, the y minus k is not. That's how we identify it as the parabola. X we have one term that is squared, one variable that is squared, one variable that is not. Okay. Also, please notice this 4p, that's a coefficient. So whatever you have, if you have a coefficient, it needs to be in front of, in this case, the y minus k. And we'll talk about that as we get into examples. Okay. Now, we have an x minus k that is squared on the other side, or excuse me, x minus h that is squared. On the other side, we have y minus k. hk is going to be our vertex. So as long as this is our equation is in this form, we can just pick out hk. That is our vertex. Okay, very easy to identify. Also notice that it is x minus h, and we're pulling h. Okay, so that's something that we'll have to be careful with. Now, you're probably going to go ahead and write these down the way that they are. But I want you to notice what they have in common, okay? Our directrix, we know, is going to be a line, and notice how this says y equals k minus b. Focus, we know that's a point. Notice how this is k plus b, okay? I do not want you to focus on the k minus p and the k plus p, and remembering if I'm adding or subtracting to the y or the x. What I want you to worry about is, you know that the focus needs to be inside of our parabola. You know that the directrix needs to be outside of the parabola. What I need you to remember is that both of these are going to be p away from the vertex. So as long as you know where your vertex is, and you know in which direction your parabola opens, you are going to know where to plot your directrix and focus, and you're going to know how far away they are. They're going to be p distance away. So this is what your parabola is going to look like. Okay, you'll have your parabola with your vertex. Inside, p distance away, you're going to plot your focus. Outside a distance of p, you're going to plot your directrix. Okay, now this parabola is opening up. What would be different about our equation if it was opening down? So what would be different?
Like, for the focus, would it be k minus b?
Well, I'm talking about way up here. What would be different? You're on the right track.
Would it be a negative p?
We would have to have a negative coefficient. Okay, 4p would have to be a negative number. Okay, if it's negative, we know they're going to open down. Positive will be opening up. Okay. Now, we have another kind of parabola to talk about. This parabola is opening vertically, up or down. We also have parabolas that can open horizontally, left or right. Okay. How do you think that those equations are going to look in a different way?
It would be right written.
Clever. I'm looking for something else. What do you think is going to change in this equation? Any ideas? Very good. Our squared is now going to be with the y, and the x is going to be the non-squared term. So if the y is squared and the x is not, then we have a parabola that's opening horizontally, left or right. Okay? Nothing else changes. Our vertex is still hk. Notice the h is coming with the x, the k is coming with the y. All right? Our directrix and focus are still p away from the vertex, but since it's horizontally, we're going to move from the vertex horizontally instead of vertically. That's the only difference. Okay. So notice how this parabola is opening to the right. That represents when our 4p is positive. If 4p is negative, then it's going to open in the negative direction to the left. Okay? Our focus is still inside p units away. Our directrix is still outside p units away. Okay? So the main thing here is when we go to graph these, first of all, they need to be in standard form so we can identify everything. You will want to identify the vertex first because everything is based off of that vertex. Okay? You need to identify your vertex. You need your p-value. So then you'll identify the vertex, the focus, and directrix. Those are the three important things about a parabola before we can actually give it its shape. Okay? Any questions about standard form before we move on? Okay, we're going to go through a very bland, basic example first, and then we'll get into ones that we'll actually have to like complete the square and do a little bit more work with. All right, so our first example is y squared equals 3x. Is this in standard form? It is. Okay, but Mrs. Homan, there's no y minus a number, x minus a number. That's because our vertex is where? Okay, here our vertex is at 0, 0. In what direction is this parabola opening? Okay, the y is squared, so it's opening horizontally. So is it right or left? It's opening right. How do we know that? It's opening right because the y is squared, not the x, and our coefficient is pi. Okay, so our vertex is 0, 0. Now, if I go back to our standard form, the coefficient in front of x is 4p. What's our coefficient here in front of x? 3. So our coefficient must equal 4p. Our coefficient is 4p. So in this equation, what is p? Okay, so if I write y squared equals 4p times x, that is the same thing as y squared equals 3x. I did not change our equation, I just had to figure out what that p value was. So now you told me that this parabola is going to open to the right, correct? Right? Which means our focus, all right, our focus is inside of our parabola, and how far inside is it going to be from our vertex? 3/4. So instead of remembering all of those little formulas that I wrote down and told you to kind of ignore, I know that the focus is inside 3/4 away. So here's my vertex, here's 3/4 away. Now I'm going to write, okay, my focus is, I'm going to look at that point and identify it as 3/4, 0. Our directrix lies outside of our parabola, perpendicular to our axis of symmetry. Okay, so our axis of symmetry is here. I'm going to move P away from my vertex. So here's 3/4 away, and I'm going to make that directrix line. What's the equation of that vertical line that I just drew? Just x equals negative 3/4. Don't worry about the x minus p or any of that. Just worry about where did I plot that line. I plotted it at x equals negative 3/4. It is much easier to remember that those two things are p units away than trying to remember the formulas. Okay? Okay? Questions? Now, I will actually have you plot a couple points so that we can actually get a nice shape to it. And I'll show you that in our next two examples. What I wanted to focus on in this example is the focus and direction. And focus on the focus. Okay, so there are no questions. Let's see. Step it up a notch. Do not panic. So first of all, is this going to open vertically or horizontally? Horizontally because the y is squared. Good. Now, is this in standard form? No, which means we're going to have to get it there. Okay? So, what I want you to notice about standard form is that the y's are on one side and the x's are on the other. Do you see that? Okay. So what I'm going to do here with our equation is I'm going to keep y's on one side, but move my x's to the other side. Okay. Now, I need a binomial square. I don't have that, which means we have to complete the square. That's why we practiced it this morning. Okay, so if I add a number to this side, I have to add the same number to the other side. Okay, so we're going to have to keep everything balanced. Okay, how did you get 4, Jimmy? Okay, so we have to take b divided by 2, which is -2. When we square it, we get 4. So how do we factor y squared minus 4y plus 4? Y minus 2, the quantity squared. Also, if you notice in standard form, the coefficient has to be factored out from the non-squared term. So, is there a coefficient for x? It is 4, so we have to factor out the 4. So now we are in standard form. Okay. Let's identify our vertex. That's the easiest thing to pick out. Where is our vertex? Very good. You are not tricked. It is -1, 2. X minus h, y minus k. Alright? So I'm going to plot that. -1, 2. And we said that this was opening to the right? Oh, we just said vertically, didn't we? Shoot. Is it opening right or left?
Horizontally.
Horizontally, I said vertically, I'm sorry. You told me this was a horizontal parabola. Now we can identify, is it left or right?
Right.
It's right because our coefficient is, our 4p is positive. Okay? So we know that this coefficient has to be 4p, and our coefficient is 4. So what is our p-value? Our p-value is 1. So this parabola is opening right. Our focus is 1 away inside of our parabola. Yes?
I don't understand the P one.
Well, in standard form, our coefficient is always 4p. And so whatever our coefficient is in standard form has to be equal to 4p.
So the second one is the coefficient.
This is the coefficient.
Yeah.
Right.
So you always use a coefficient you said equal
To 4p. To determine what
What
p
there
is.
is no coefficient?
Then it's 1. 4p is 1.
1/4.
So that would mean p is 1/4.
Okay.
Yes. I'm talking about your coefficient would be considered 1, and you set that equal to 4p. Okay? All right, so p is 1, which means inside of our parabola, we're going to move 1 away for our focus. Now that we've plotted that point, we can identify it as 0, 2. Okay. Then we need to move p away the other way for our directors. So I'm going to move 1 in the other direction, and I know our directrix has to be perpendicular to the axis of symmetry. So our directrix is what line? X equals -2. Okay? So we have the 3 important things identified. We identified the vertex, the focus, and the directrix. All we have left is the shape of our graph. If you recall back from chapter 1, depending on the coefficient, our parabola was wider or skinnier, correct? Now, what we're going to do to get its exact shape is actually use the definition of a parabola. Okay, I'm going to go back to here. I want you to notice this right here. This point on this particular parabola, the distances from the focus to the directrix are perpendicular, which means we could actually count those distances, couldn't we? Okay? Every time you are going to have a point on your parabola every time where this is true, where you have perpendicular distances. And it's going to happen when you double P. Alright? So if we are to double P, what is double of P? 2. So if we double P and we move that distance from the focus to plot 2 points, notice how those 2 points are 2 away from the focus and 2 away from the directrix. Okay, so we're satisfying that property.
Why did you double it?
Why did I? So we could get the property to work. If you double P, then you can move that from the focus and you'll be that same distance from the directrix. If you double P, you're at this point right here, where we can actually count the distances to each of these. Okay? Distance only works if we have perpendicular distance, otherwise we have to use like the distance formula and it gets all complicated. Okay, so if you double P, I'm telling you, double P and you will get these points that are equidistant from the focus and directrix. Every time, if you double P, that will happen. Okay, questions? All right, let's look at another example. Okay, first of all, does this open vertically or horizontally? Vertically, right? Up or down, right? Can we tell right now if it's up or down? It's going to be down. Now, this is an equation that you're used to seeing like in Algebra 2, right? This is kind of the form that they would be in. Okay? Unfortunately, this is not the form that we want, is it? This is not standard form. So we're going to have to get it to standard form. Okay? First of all, the coefficient in our equation always goes with which term? Where's the coefficient? With the term that is not squared. Where do we want our coefficient? With the y. So I'm going to multiply -8 over. Okay. Now, I want a binomial squared with our x squared plus 2x. Is that 33 going to be helpful? No. So I'm going to move it to the other side because it is not going to help me complete the square. Okay. So now I've rearranged everything. Let's go ahead and take x squared plus 2x and complete the square, which means we're going to have to add something, and I can't just add it to one side. We're going to have to add it to both sides. All right? So, what is b over 2? 1. 1 squared, 1. Okay. So I have negative 8y minus 32. What is this right side factor to? X plus 1, the quantity squared. Okay? Now, are we in standard form? No. That coefficient has to be factored out of the non-squared variable. So, we need to factor out a negative 8, which leaves, very good, y plus 4. Now we are in standard form. Once we're in standard form, the hard part is over. Okay, now we just have to identify everything. So, where is our vertex? Okay, be careful. You are going to want to say negative 4, negative 1, but the x has to come first. We have x plus 1, so negative 1 is our x for the vertex. Negative 4 is the y for the vertex. And make sure you pick x then y. So negative 1, negative 4. There is my vertex. Our coefficient is negative 8. And our coefficient always has to be 4p. What is p? Negative 2. Now, you told me that this is opening down, which is why p is negative, right? So since this is opening down, our focus needs to be 2 away on the inside, which means we're going to move down to plot our focus. Okay? The p is negative because it's opening down, but you're still going to move a distance of 2. All right? So our focus is the point, negative 1, negative 6. Our directrix is going to be to the other direction. It is a horizontal line, so now it's y equals negative 2. Okay? And how do we plot points? Not squared. We're going to need double P. Double P. Double P is 4. So from our focus, we'll move 1, 2, 3, 4. 1, 2, 3, 4. And you'll notice that those points are also 4 away from the directrix.
You always do that at focus.
Yes. So that we can hold that property. Only points you need. Okay, to get your shape. Okay. All right. So, here's your homework.